where you can publish very fast. One is environment energy, the other one is finance. I have published 11 paper in 1 year in finance journals just by changing the specification of the test. So it's very easy. So you can publish so many papers in finance. It is very relevant, you can see the field, because you know that the financial stock markets generate data on seconds. That is why there is a huge amount of data. If you want to estimate a single day impact, you can take data on minutes. So how many minutes in a day? You can answer 12 and 60. So there are more than 100 observations. So it means that you have more than 100 observations on one day. So you can easily estimate the impact of an event on the stock market. So that is why it is very relevant. I have published very paper with COVID-19. Now I am working on Ukraine and Russian war. So you can also do it. So we have a series of closing prices of SP500. Let's start from pre-testing. We pre-test this series and we came to know that there is an arch effect. That is why we are going for arch guard type modeling. Let's start with the model, select financial data, formulate. Series is already selected. Okay. Now we are on specification. As you know that I already told you there is a ARMA process in the conditional mean equation and there is a specification in Garch type modeling or conditional variance equation. So the first step which shows that the RFIMA or ARMA, autoregressive, fractional, integrated, moving average, so there are so many ARMA type models. So the ARMA order shows that what is the specification of your conditional mean equation. And the Garch order shows that what is the specification of your conditional variance equation. So we just try to put 1, 1, 1, 1. It means that we are running a model with ARMA 1, 1 and Garch 1, 1 specification. Okay, done, and this we have results. The results are very significant. What we did with that? No, sorry. We didn't select the model. So we work with Garch. Let's start with Garch. No, you can see that the T probe shows that all the values are significant. It means our model is good fit. Apparently, at first sight you can say that it is a good fit model. The second is try to see that is there any value in conditional variance equation is negative? No. All values are positive. So the next observation shows that the model is good fit. Now the third one is persistence of shock, which is a combination of the parameter of arch term plus parameter of Garch term, alpha plus beta or gamma plus delta according to our equation. So we have to sum up these two magnitudes. Then it must be less than 1. It must be less than 1 for a valid model, because if they are equal to 1 or greater than 1, then we can say that the model is not a persistent model. Model is not a valid model. The model is unable to estimate or forecast the future. So the value is 1.08555. It means the model is not good fit. But before the decision, we have to go on the residual analysis to check the validity of this model. So for this, we again go on test, select test.
Sir, can you please repeat the reason why value must be less than 1?
Because it is a persistence of shock. It shows that how much time your shock will take to persist in your series. When this value is 1, it means the 100% time. So it means it always persists in your model. So if always persists in the series, then how we can estimate a valid forecast? So it is impossible. Basically, it looks like a equilibrium diversion problem like ECM. We are saying that if the value is close to 1, it means it takes long time to convert to the equilibrium value. But if it is less than 1, then it takes less time to convert to the mean value or equilibrium value. Same is the case here. If it is close to 1, it means that it takes a very long time to die out the arch and gauge model effects, arch and gauge effects. But if it is less than 1, then there is a chances in short period the arch and gauge effects will die out from the series. So this is another thing. Now we run the residual analysis. We can see all the residual testing is insignificant. It means that the model is good fit. Suppose if there is a significant value, it means the arch effect is still persisting in your series and the model is not good fit. Because all the things shows that they all tests are insignificant, it means the model is good fit. But we have problem of alpha plus beta, which is more than 1. Yes. No, we are required arch effect in the series, but these are the residual analysis. But after fitting the model, why we are fitting the gauge model? We are fitting the gauge model to capture the arch effect. If our model is unable to capture the arch effect and still it persists in the residuals, then why we are fitting the gauge model? We are fitting it to capture the arch effect. If your model captures the arch effect from the series and the residuals are normal, then it is a good fit model. But here we are facing a problem with persistence of shock, which is alpha plus beta, which is greater than 1. Now we have to go on the next model, arch model, or we can change the specification of this model like this one. We just try to add another lag of autoregressive, 2 lag of autoregressive, then try to estimate this one. No, it is 1.07, but the term is AR1 is insignificant, AR2 is insignificant. It means we just add an extra term, but the remaining term is also insignificant. No, it is not at 5%. Yes, basically our test is on 5%. That is why we are considering it. But for the sake of convenience or to show our result is good fit, you can show that it is significant at 10%. Let's try to increase the lag of MA term. Now, again there is insignificant values and the persistence of shock still greater than 1. So the another thing is we just go on next model. Maybe there are some factors which the Garch model is unable to capture. That is why the persistence of shock is not dying out. Because we have seen there is a large break in the series, it means there is a special effect in the series. So the Garch model is unable to capture the special effect. So we have to move on next generation of Garch model, which is GJR model. So it is known as GJR Garch model. GJR. I will show you the equation of this model before this estimation. Okay. Still the sum is equal to 1.07414. But the problem is that the GJR gamma is also insignificant. So we have to change the specification of this one. Insignificant, no, it means that GJR is unable to estimate the effect and we cannot apply GJR model on this series. So we have to go on